What's up guys, in this we are going to see about the linked list demo in Java. So linked list is a data structure used for storing collections of data. Linked list has some of the following properties which are, the successive elements are connected by pointers, which we have seen in the last tutorial. Last element points to null. It can grow or shrink in size during the execution of a program. It can be made just as long as required until the system memory exhausts, right? And it does not waste any memory space but takes some extra memory for the pointers, right? So there are many other data structures that do the same thing as that of linked list. Before discussing linked list, it is important to understand the difference between linked list and arrays. Both linked list and the arrays are used to store collections of data. Since both are used for same purpose, we actually need to differentiate between their usage. So what is the advantage of using a linked list as well as disadvantages? So linked lists have both advantages as well as disadvantages. The advantage of linked list is that they can be expanded in constant time. To create an array, we must allocate memory for a certain number of elements, which we have seen in the arrays demo. To add more elements to the array, we must actually create a new array and copy the old array into the new array. This can take a lot of time. We can prevent this by allocating lots of space initially, but then you might allocate more than what you need and waste memory. With a linked list, we can start with space for just one element allocated and add on new elements easily without the need to do any copying and reallocating, right? So the main disadvantage of linked list is in access time to individual elements. Arrays in random access. So array is basically a random access, which means it takes in O of one time. So it's basically a constant time. But whereas in linked list, it takes a linear time, which is big O of n, right? So these are called as time complexities. So big O is actually a time complexity, which discuss about the worst case scenario. So let's actually deep dive into the collections linked list demo. So I have created a class called as linked list demo inside this list, right? And let's create a linked list object, right? So I'm going to create a linked list object and I'm going to provide a generic of string, and I'm going to have a names object with a new linked list. So I've created a linked list object which is of type string, right? So this linked list will hold an object of type string, and let's go into this linked list class. So if you see in this linked list class, this actually implements the list interface as well as it also implements the DQ interface, right? So these actually provide us various methods, and for the nodes which we are talking, or rather the pointers, this is where you actually create the pointers, right? So if you go into this class which is called as a node, it has a pointer for the next as well as for the previous, and this is actually an element item, right? So this node actually, this is where all the magic happens in linked list. So let's go into the demo. So to add an elements inside a linked list, what you do is you do the same as array list. So names.add, I'm going to add a spawn, first name, this is a default name. I'm also going to add some names. Let's say I'm going to add John. I'm going to add one more which will be called as, let's say, Henrik, right? So let's do S out on this. What I'm going to do is names.toString. This will actually print out what is the content. Along the same line, you can have size of linked list, right? You can concat this as names.size. This will actually return the size of the linked list. You can also do s out, you know, element at 2, rather index 2. More precisely, I can, get the index at 2, right? So this is the maximum right? If I try to access the third, it will give us an index out of bound exception because we have only added 3. And as index starts from 0, so at 0 we have Spawn, at 1 we have John, and at 2 we have Henrik. Also, what I'm going to do is I'm going to add, let's create one more linked list, right? So I'm going to, call this as, sorry, a linked list of string. I'm going to create a linked list of string, let's say names1 here, and I'm going to create an object for that, and I'm going to add in names1 some names here. So here I'm going to add, let's say, Walter, and again I'm going to add, let's say, you know Lawson, right? So I'm going to add the name as Lawson. So just like array list, we can actually add names1 into the names linked list using, you know, the add all method. So I'm going to use this add all method, and I'm going to add names1 here. And let's print out the contents of names, right? Also, you can do some operations like names.add, rather add at, let's say, if you want to update or add at a specific index, you can do that. So I'm going to I'm going to add at index 2, and I'm going to name this as Henry, right? So although we have an element at index, so this will do an update operation, right? And if you don't have an element in the element at index, it will actually add it, right? Along the same line, we can use set method, which is also fine. And I'm going to do an s out of names dot toString, right? This is going to have a toString. So I'm going to run this code to show you the output. So if you see here, when I added these elements inside a linked list, and if I do the names.toString, I have 3 elements. The size of linked list is 3. So element at index 2 is Hendrik, which I have told. I have added 2 name and did an add all operation, and when I printed the names linked list, I have 2 more entry, which is called as a Walter and Lawson, right? And then I have printed a toString, and then I have added the element at index 2, which is the Henry. Previously it was Henrik, right? I updated Henrik to Henry, and this is the updated list. Also, what you can do is you can use an iterator here. So what you can do is you can use an iterator. This is, as this linked list is of type string, so you need to use a string iterator, and I'm going to iterate through this, right? So while iterator dot has next, you need to have an has next. Let's print out you know the iterator dot next, right? So I'm going to format this. So this, I'm going to name this as iterator, uh, right? Iterator value. So I'm going to have a plus sign here. Also, there is something called as a list iterator right here. So I will tell you what is the advantage of list iterator. So I'm going to create a list iterator, and I'm going to again call a list iterator, right? While list iterator dot has next, right? You can do s out list iterator next. So I'm going to format this for better output at console, list iterator next, and I'm going to print a list iterator dot next, right? But this is next. What if you want to move from the end of the list to the 0th element, right? So whenever we are doing has next, we are actually moving from the index 0th to the size -1. But what if you want to move from the last element to the 0th element? So using list iterator, you can do that. What I'm going to do is while list iterator dot, so for that I actually need to create one more list iterator. So I'm going to create, rather I'm going to use the same list iterator is equals to names dot list iterator names dot size. So basically what this will do is this will start iteration from the last element, right? So as I want to move backward now, so I can use list iterator dot has previous. You need to do, the s out, and I'm going to have list iterator previous, right? Previous, and I'm going to print this up list iterator dot previous. Also, I'm going to have some, formatting here. So I'm going to use this hyphen, right? So this is one thing, and then I can, paste it here, and again I can paste it here, right? So let's run this code and let's see what is the output. So we have seen about the first section, right? So let's see about the iterator. So if you are iterating through each element, this is how you create an iterator. This is same as what we did in array list. So iterator dot has next. If it has next, just get the next element. So this is what it actually does. So it starts from spawn, it ends at Lawson. Also, you can do a list iterator. It's same as what iterator provides, but also it has one more functionality which is called as a previous, right? So previous actually starts from Larson and it goes till spawn. So if you notice at the above, it starts from spawn, which is at 0th index, to you know till the end of the list. But if you use the previous method here, right? If it has a previous, if you are using this previous method, this actually starts from the end of the list, linked list, to the 0th position, right? So this is all about linked list. Is there are also other methods. So if you could see here, you can do for each, right? You can do for each, and you can use lambda expression. Inside this, you can do, s out p, right? So what this will do is this will actually print out each and every element using for each, right? So let's actually do some formatting. This is for each, and this is it. So let's run this for the for each as well. So if you run the code, you'll see the output just as what we did for the iterator. You can also use for loop, traditional for loop, which starts from I is equals to 0, right? The traditional for loop which we seen for the array list. You could also use the enhanced for loop as well. So this is all about linked list. So in the next tutorial, I'm going to come up with a new collection type. Till then, goodbye and see you in next tutorial.